Welcome everyone. The question is from the semiconductor devices. A germanium crystal is doped at temperature with a minute quantity of boron. The charge carriers in the doped semiconductor will be option A electrons, option B holes and few electrons, and the next option is electrons and few holes. So at first we try to dive a little bit in basic. Why germanium crystal? What is semiconductor? Okay, listen. When the conductor is designed, at first we try to conduct the current, the electrical energy through it. But one of the very popular problematic backlog of it is resistance variations with the temperature. If you increase the temperature, then the resistance is increased like this linearly. The formula is R theta equal to R0 into 1 plus alpha theta. The material which have the large amount of temperature coefficient of resistance, okay, that material's resistance is increasing enormously, and resistance increases so much there is lots of power is lost. You want to transfer the electrical energy, and the loss of electrical energy is lost in overcoming that resistance. So it is problematic. So scientists have designed, and we can say basically find it out, a type of material which is called the semiconductor. Okay, the semiconductor is basically made up of the quadrivalent atoms. Okay, silicon, germanium, this type of atoms are taken, not carbon. This type of atoms are taken, which somehow creates a covalent bond with other atoms and forms a lattice structure or the crystal like this way. Just like the carbon, the catenation property have. Catenation property, it can create the bond with any of it, but it is not like that. But there is a bond is formed because the valence of germanium is 4. So obviously, any one of the germanium atom basically creates the single covalent bond with the other 4 adjacent atoms and becomes chemically stable. But what will happen if the temperature is increased? If the temperature is increased, then this covalent bond ruptures. Okay, then this covalent bond ruptures, and when this covalent bond ruptures, we can say the electrons which is basically taking is of this germanium and this germanium, which is basically taking part in the covalent bond. Due to the thermal energy, it just comes out from the lattice phase. Okay. Now, the increasing temperature basically helping in freeing the substances, that is electrons, which is available for the conduction. What are electrons? Electrons are basically taking part in conduction. Before that, the increasing temperature is obstructing the flow of the electrons. Now, the increasing temperature generating electrons. Not only generating electrons, from where the electrons comes out, at that particular place there is the absence of the electrons, and they name this absence of electrons as a holes. Okay, this also becomes a carrier. Okay, so when an electron just jumps out from its lattice space, two different types of carrier is developed within the lattice space. Okay, one is hole, another one is the electron, because hole is not a particle, you cannot get it outside the crystal lattice. Okay, obviously it is not the antiparticle of the electron, for the same reason, because you can't get it outside the lattice. It have all the characteristics to be an antiparticle of electron, but it is obtained only in the lattice. So by rupturing one covalent bond, okay, we are getting the electrons and the holes. Okay. Now what will happen? The scientists basically not stop here. They have already revised something of which resistance is decreasing with the temperature enormously and conductivity is increasing. But now they want something advanced. What they can fabricate, what they can change according to their need. Okay, so now they use the dopants. Okay, what is dopants? Dopants are basically nothing but two different types of atoms which have the either trivalent impurity or the pentavalent impurity. The most popular, they have taken the aluminium or the boron. Aluminium is the, obviously you know, the trivalent one, and the boron is the pentavalent one. Now think, in this germanium lattice space I have just placed one boron. Okay, I have just placed one boron here. Okay, let me draw. Now borons hold electrons in the valence shell, basically creating the covalent bond with all other adjacent germanium atoms. Plus one electron is left. Okay, now this is bound to that particular boron, okay, and not creating the covalent bond with the other germaniums. Okay, now think, if you increase the temperature a little bit, what will happen? The electron in the valence shell comes out. Okay, electron in the valence shell comes out. We have learned about the work function. If the energy is enough to take that electron out from there, it just comes out. Now, just increasing the temperature a little bit, we are getting the carriers. Now, if you increase the temperature again the same phenomenon will occur. The covalent bond will rupture, the electron hole pair will generate. So, we can increase the conductivity by the controlled fusion of the trivalent or pentavalent. Okay, so what will happen? Conductivity has increased much more than that of the simple intrinsic germanium semiconductor if you fuse some dopant, either trivalent or pentavalent. Since we have doped boron here, we are getting the electrons. So electrons is more than that of the holes. Why? Because when you just increase the temperature, the electrons comes out from all the borons, and if you increase the temperature more, then what will happen? The bond will rupture and the electron and hole will come out. Okay, so here the electrons are more in number than that of the holes. So electrons are the majority carriers here. Since the negative type of charge carriers are more here, so we can say this is a N-type semiconducting bar. And vice versa, same the case happens for the P-type semiconducting bar. Now the boron and the aluminium, that's a trivalent or pentavalent one, which are just fused here in a controlled fusion that have a ratio. Then the ratio is 10 to the power 6 is to 1. If there is 10 to the power 6 germanium atoms, I have taken one boron atom, the minute one. But just think of, you can't take one germanium, you have to take a germanium crystal. And if you have taken 1 mole germanium, then 10 to the power 23 germanium if you have taken, then the boron need to fuse here 10 to the power 17. It is not a small n number. If you do the unitary method, then obviously you will get this. Then lots of electrons you will get if you increase the temperature little bit. Now further increase will gives you more and more electron and holes. Okay, so let us read the question again. Germanium crystal is doped with at temperature with a minute quantity, minute means here very small, quantity of boron, and the charge carriers in the doped semiconductor will be electrons only. Boron is the pentavalent. Obviously it gives rise to more electrons but less number of holes. So we can say electrons and the fewer holes. That is the correct option here. Thank you all of you.